So here's a quick video to help us predict products in chemical reactions. It's all about finding the patterns, looking at what information you have in the reactants, and making a good guess as to what reaction is going to occur. So here are 5 examples of chemical reactions that fit into our 5 main categories of types of reactions. So here I have 2 single elements. There's no way for them to trade pieces because they're 2 things, 2 single elements. The only thing they can do is squish themselves together. And so we're going to end up with N's and H's. And because nitrogen has 5 valence electrons, I know that it needs 3 hydrogens to fill that octet rule. So we're going to make nitrogen trihydride, which is also called ammonia. So if I have 2 single elements, the only kind of chemical reaction that can occur is for these guys to squish together to make a single compound. And this, of course, is our synthesis reaction. I need to balance it. I've got 2 nitrogens, only 1 over here, so I'm going to put a 2 in front. Now I have 6 hydrogens. I'm going to put a 3 in front of that guy. Next one, I have a single reactant, 1 compound in the reactants. The only thing that this guy can do is break apart into its elements. It's going to break apart into magnesium and oxygen. This is our decomposition reaction. Remember that oxygen is in Brinkel-Hoff, which means that it's going to be O2. So now I need to balance this guy. I need to put a 2 here so that I have 2 oxygens and 2 oxygens. And now I also have 2 magnesiums, so I need a 2 here. This one, remember when we see oxygen in the reactants, oxygen gas in the reactants, this is going to be a combustion reaction. Combustion reactions with hydrocarbons. This is a hydrocarbon because it has hydrogen and carbon, hydrocarbon. The reaction is always going to produce carbon dioxide and water and some energy in a combustion reaction. To balance this guy, I've got 1 carbon, I've got 1 carbon, I have 4 hydrogens, I only have 2. I'm going to put a 2 in front of the water. Now I have 2 oxygens here and 2 oxygens here, so I need to put, my box is too in the way. So I need to put a 2 in front of the oxygen gas, and I have 4 oxygens here. 2 plus 2 makes 4 over there. All right, the next guy, I have a single element and a compound. This is going to lead us to a single replacement reaction. Single element compound. This is different from single element. That's going to lead to synthesis. Single element compound. Now this one is single replacement instead of combustion because it's not oxygen. I don't have any oxygen gas in here, so it's not combustion, just single replacement. What's going to happen is these 2 guys are going to trade places. So instead of having hydrogen on the chlorine, I'm going to put the sodium on the chlorine. And instead of having sodium single, I'm now going to have hydrogen single. Remember that hydrogen is in Brinkel-Hoff, and so this needs to be H2. I have 2 hydrogens, I need 2 hydrogens, but now I also have 2 chlorines, so I need 2 chlorines, but now I have 2 sodiums, so we need 2 sodiums. Last one, I have compound. There is no single element, and I have more than 1 compound, so it can't be decomposition. There's only 1 compound. I have 2 compounds. This is going to be our double replacement reaction. So these 2 metals are just going to trade places. So instead of sodium on the chlorine, I'm going to put the barium on the chlorine. Instead of barium on the oxygen, I'm going to put the sodium on the oxygen. So we're going to get barium on the chlorine, and we're going to get sodium on the oxygen. Problem with this reaction right now, barium is a +2 charge, chlorine's a -1 charge, so that's not quite right yet. I need 2 of those to balance out. Same thing over here with my sodium oxide. Sodium's a +1, oxygen's a -2. I need 2 sodiums to balance out that oxygen. Now I have 2 chlorines and 2 sodiums. I'm just going to put a 2 in front of sodium chloride in the reactants, and voila. All right, so pause the video, make some predictions about these reactions. I'm going to give you a hint. They go in the same order as the previous slide. All right, so hopefully you paused the video, made some predictions. Now let's check some answers. I have 2 single elements. That's going to make this synthesis. These guys are going to combine. We're going to make cesium chloride. Cesium's a +1, chlorine's a -1, and so this is already balanced out, but I have 2 chlorines, so I need a 2 here and a 2 here to balance the equation. Lithium bromide, I have a single compound. This guy is going to break down into its elements, lithium and bromine. Decomposition reaction. Remember in Bringelhoff, bromine is going to be diatomic. It comes in 2s. So I need a 2 here and a 2 here to balance. Oxygen gas in the reactants makes this combustion. My products of a hydrocarbon and combustion are always going to be carbon dioxide and water. I have 2 carbons, I need 2 carbons. I have 6 hydrogens, so I need 6 hydrogens. Now I have 2 times 2 is 4, plus 3 is 7 oxygens, but over here they come in 2s. So I could try to throw in a 3.5, because 3.5 times 2 makes my 7 oxygens, but that's not quite going to cut it. So what we're going to do is just double everything. So instead of 1 C2H6, I'm going to have 2. Instead of 3.5, we're going to have 7. Instead of 2, we're going to have 4. And instead of 3, we're going to have 6. 2, 7, 4, 6 is the balanced combustion reaction. All right, this next guy, I have a single element and a compound. Single element plus compound. We're going to have a single replacement reaction. These guys are going to trade places. So instead of aluminum by itself, we're going to have aluminum on bromine. And instead of hydrogen in bromine, we're going to have hydrogen by itself. All right, lots of things to think about. Aluminum has a +3 charge, bromine's a -1, so I need 3 of these guys. Hydrogen is in Bringelhoff. It always comes in pairs. It's diatomic. I have 2 hydrogens. I have 3 bromines. So I need a 2 or a 3. I need both. We're going to combine 2 and 3 and make 6 hydrobromic acids. So I have 6 hydrogens. I'm going to make this a 3, so that I have 6 hydrogens. I have 6 bromines. I'm going to make this a 2, so I have 6 bromines, and now I have 2 aluminums. Equation is balanced. Last one, I have compound, no single elements, no oxygen gas. More than one compound is going to make this a double replacement reaction. My 2 metals, potassium and lithium, are going to trade places. So instead of potassium on carbonate, I'm going to put potassium on hydroxide. And instead of lithium on hydroxide, I'm going to put lithium on carbonate. Lots of things to think about. Balancing charge-wise, potassium's a +1, hydroxide's a -1. This is good. Lithium's a +1, carbonate's a -2. This is not good. I need 2 lithiums to balance out that carbonate. Now I need to balance the equation. I have 2 lithiums. I only have 1 lithium. I'm going to put a 2 in here. I have 2 potassiums, and now I have 2 hydroxides. I'm going to put a 2 here, and my equation is balanced. Again, here we have synthesis. Here we have decomposition. Here we have combustion, single replacement, and double replacement. Synthesis, we have multiple single elements that combine to make a compound. Decomposition, we have a compound that breaks down into its single elements. Combustion, we have oxygen gas in the reactants. If I'm combusting a hydrocarbon, a compound that's composed of only hydrogen and carbon, we're going to produce CO2 and H2O. Here is a single replacement. I have a single element and a compound. The 2 things are going to trade places. Here I have double replacement, compound. 2 things are going to trade places. All right, we're going to do one more practice slide. This one's a little bit trickier because it is not in the same order as the last 2 slides. Pause the video, work out some answers, come back and check. hopefully you are ready for some answers. Since I have compound, this one is going to be a double replacement reaction. I'm going to trade my two metals, the magnesium and the sodium. So instead of sodium on fluorine, I'm going to put the magnesium on the fluorine. I'm going to put magnesium on the fluorine. And instead of magnesium on the nitrate, I'm going to put sodium on the nitrate. We're going to make sodium nitrate. You need to think about some charges. Magnesium's a +2, fluorine's a -1. That's not going to work. I need F2. Sodium's a +1, nitrate's a -1. That's good to go. But now my equation's not balanced. I have 2 fluorines and only 1 fluorine. I need a 2 here. But now I have 2 sodiums, so I need a 2 here. And now I have 2 nitrates, but that's okay, because I already had 2 nitrates. This guy, I have single element, 2 elements by themselves. The only thing they can do is combine in a synthesis reaction. We're going to make calcium fluoride. This is a synthesis reaction. Calcium has a +2 charge, fluorine has a -1 charge. I need it to be F2. It's already balanced. Look at that. This guy, I've got oxygen gas in the reactants. That's going to make it combustion. Since I have a hydrocarbon, hydrogen and carbon only, our products are going to be carbon dioxide and water. To balance, I have 2 carbons. I need 2 carbons. I have 4 hydrogens, so I need to make this a 2. 2 times 2 is 4 hydrogens. And now I have 2 times 2 is 4 oxygens plus 2 more is 6 oxygens. I need this to be a 3. I have a single element and I have a compound. A single element and a compound is going to lead to a single replacement reaction. Magnesium and manganese are going to trade places. So instead of manganese on the oxygen, I'm going to put magnesium on the oxygen. And instead of having manganese with oxygen, manganese is now going to be our single guy, because this is single replacement. Check our charges. Magnesium is a +2, oxygen's a -2. That's good. But I've got 2 oxygens, so I need 2 oxygens. Now I've got 2 magnesiums, I need 2 magnesiums. Last but not least, I have a single compound. It's going to have to decompose. That's the only thing a single compound can do by itself. So we're going to go through a decomposition reaction. The sodium and the oxygen are going to separate into their elements, sodium and oxygen. Remember that oxygen is in Brinkelhoff. So oxygen comes in O2s. I have 2 oxygens. I only have 1. I need to make this a 2. Now I have 4 sodiums. I need 4 sodiums. Hopefully that's a help to get you started on predicting products. If you have more questions, let me know.